Okay, so in this third domain of the differential equations, what we will be taking a look at is solving differential equations by using the separation of variables process. Okay. So generally, remember, what you will want to do is you'll first want to multiply by dx, and then get all the y's and x's on their own separate sides. So you'll have something times dy, and then something times dx. And then what you're going to do with that is you're going to do the integral of both sides. And then antiderive, get plus c's, and then plug in points to find particular solutions. There's a lot of steps to these, but they are some of my favorite problems because even though there are a lot of steps, that means there's a lot of opportunities to earn points on this. You can reliably get 4 or 5 points just from this one part C in this problem, and that means that you can get you can increase your overall free response question average just by getting really, really good at differential equation problems. All right, so let's take a look at this first one. Number 5 on AP 2011, Part C. So this is a no calculator problem. It says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. W is an increasing function. Models the total amount of solid waste stored at the landfill. And then we've got this differential equation right here. W is measured in tons, and T is measured in years. And then in part C, it says we want to find the particular solution. Okay, so this is our big hint to use separation of variables and to solve this differential equation using that. So let's go to it. So I'm going to just start by rewriting the differential equation. dw dt equals 1/25 w minus 300. Now the first thing that we're going to want to do here is to multiply the dt over to the other side. Why don't you do that and then try taking it the rest of the way, see what you can make of it, and check your work with me once you've done that. Okay, so I'm going to multiply both sides by dt. And then I see that I've got w's with this dt right here. So I've got a w with this dt. I don't want that. So I'm going to divide the w back over to the other side. So dw over w minus 300 equals 1/25 dt. From here, you can see that I've got w's with dw and t's, or just a number with dt. So what I can do now is take the integral of both sides and see what I would get. So this left side integral, I want you to know that pretty well. If you don't know it, you can kind of learn to recognize it by doing a little u substitution. So you would do u equals w minus 300, and then you would see that dw would be equal to du over 1. It wouldn't change that much. This integral would end up being a 1 over u pattern, which is an ln integral. So this antiderivative becomes ln of the absolute value of w minus 300. And that would be equal to, and then this right side antiderivative is much easier. I want you to make sure you don't make any mistakes on the antiderivative that's easiest to you. Make sure that you get those right, because that's how you start to earn your points, is just doing what you already know how to do correctly. So when I antiderive 1/25 in terms of t, I have 1/25 t. And then I need to remember my plus c. So I'm going to take this solution, which is my general solution right now, and I like to work on solving for w at first, or solving for y if this were y. So in order to do that, what I'm going to do is exponentiate both sides by using e to the power of, and I would get w minus 300 equals e to the 1/25 t plus c. which is equivalent to writing CE to the 1/25th t. And then if we add in the 300, move it over to the other side. So boom, here is my general solution. It's not my particular solution because this C is not solved for yet. So let's go in and let's use that point to try and solve for the C. If you haven't done this yet, try for yourself first. Okay, so what we're going to do is take the point that we're given, 0, 1400, and plug in 1400 for W. Right here, I like to mention we're finding C. 1400 equals, and then C, E, I'm plugging in 0 for T. 0 times 1/25th is 0. And then E to the 0 is 1. So 1400 minus 300 equals C. So that means that C is equal to 1100. And once you find that, you want to make sure that you write your particular solution by plugging this number back in to the general solution. So we would write W equals 1100 E to the 1/25th t plus 300, and box it up and call it a day. Okay, try a few of the other differential equations, solving them by separation of variables. Again, they take a while, I know that, but make sure that you're getting all the points that you can on these because they really are a source of great, cheap, easy, free points. You just need to show your knowledge at each step. And be sure that you're checking your work against the rubric so you can see what kind of points they value and what kind of things they're looking for too. The next thing I'll be taking a look at is 2014 C from Group B, but you should try a few of them on your own first. All right, so here we are at the second part of Domain 3. So I'm in Group B looking at 2014 C. We are ready to separate some variables here. So what I've got, this is a pure math problem. I've got dy dx equals 3 minus y, and then cosine of x. And as you'll see here, this differential equation involves a couple more tricky antiderivatives to it. One antiderivative is not so bad, but the other one has a little bit of a trick to it that you don't want to forget about. So let's take a look. We're taking a look at part C. So the first thing that we're going to do here is rewrite the differential equation. 3 minus y times cosine x. And then we're going to start separating the variables. Why don't you go ahead and try this, multiply by dx first, move everything over. I'm going to do this in one step, and then we will see where to go from there. So you try separating the variables and then see how far you can go, and you can check your work against mine afterwards. Okay, so I've separated the variables right here. You can see I've got my y's with dy and my x with dx. What I'm going to do now is take the integral of both sides. And when I take the integral of both sides, the first thing I want to notice is that one antiderivative is always easier than the other antiderivative. So let's do that antiderivative first to sort of build up our confidence. So the antiderivative of cosine, okay, what function when you derive it gives you cosine? That would be sine of x. There we go. So sine of x plus c. And now when I antiderive this side, I don't immediately know what it is. Maybe I think I do, but I feel like I should probably just do a u substitution here just to make sure. I'm going to pick u equals 3 minus y. And then my dy would be equal to du over negative 1. And what that's going to do is it's going to turn this integral into 1 over u times du. Remember, it doesn't really matter where I write the du. I can write the du right here, or I can put it on the top of the fraction. Either way, like, it doesn't really matter. They kind of blend. However, do be aware, though, that since I had this negative 1 right there, I need to pull out a 1 over negative 1, which in other words is a negative 1. So I might recognize this antiderivative as an ln antiderivative, but I need to put the negative in front in order to make this thing work. That's the trick here. Tons of people are going to forget about that negative in front, and I don't want you to be one of those people. So let's write this. Negative ln of 3 minus y. Now we're just going to go ahead and tackle this like we did before. So I'm going to start solving for y. That's my habit. I like to solve for y first and then plug in the points to get what c would be. So I'm going to first start out by dividing both sides by negative 1. This basically just flips the signs on things. And then I'm going to undo the ln with an exponential. We get 3 minus y equals, and then ce to the negative sine of x. And then the way that I like to think about this is I like to think about adding the y to the other side and then subtracting the ce to the negative sine of x away. So that would end up giving me y equals 3 minus ce to the negative sine of x. You might also prefer to think of it as negative sine of x. Oh, excuse me, not negative sine of x. That was silly. Negative ce to the negative sine of x plus 3. That's the other way to write it. Okay, so this is our general solution. That's what this is right here. In order to find the particular solution, we want to plug in the point that we're given. We're given 0, 1. So to find the particular solution, what we want to do is find c first. So let's plug in 0, 1. So I'm going to plug in 1 for the y, and then 3 minus ce to the negative sine of 0. And then on the unit circle, sine of 0 is 0. So this would be 1 equals 3 minus ce to the 0. So this means that c is equal to 2. So I can take this and put it in my general solution and make my particular. Y equals 3 minus 2e to the negative sine of x. And remember that this 2 is grouped with that e, so you can't do 3 minus 2 equals 1 or anything like that. They're paired together. Here, all we would have to do is box this up and call it a day. Okay, why don't you try the next few? Really, remember, this is about trying to earn as many of these points as you can. Each one of these separable differential equations has like 4 or 5 or 6 points on it. You want to try to get as many of those as possible, as reliably as you can. Try the next few problems, and then remember to check your work and check the scoring rubric as you go. All right, so in this third group, we don't often have some very complicated integrals. Like sometimes they get complicated, like in the 2017 problem, as you'll see at the end. But sometimes what's difficult about this last group, this harder group, group C in the domain, is that the algebra of them is just a little bit trickier. It's just weirder than normal. So in this particular part C, again, we've got a pure math problem here. Here's the differential equation. We want to find the particular solution with the condition that f of 1 equals 2. So pretty straightforward setup. I'm going to rewrite the differential equation. And then what I'm going to do is separate my variables. Why don't you give this a shot, see what you can make of it, and you can check your work against mine after you try it for yourself first. Okay, here's my separated variables. Hopefully you've tried as much of this process as you can before you've come back. So here's how we're going to set this up now. After we've got the variables separated, I'm going to do the integral of both sides. And like my habit usually is to do the easier antiderivative first. That is definitely that side. I know that in my sleep. The antiderivative of x is 1/2 x squared plus c. And then this antiderivative right here, it looks strange. You might want to say that it's an ln of y cubed, but this is not. We want to not u sub, but we want to think of this as the integral of y to the negative third power. So when we antiderive that, we boost up the power to y to the negative second, and then we put a negative 1 over 2 in front, or 1 over negative 2. So this antiderivative would end up becoming negative 1/2 y to the negative second. All right. So this is actually one of the problems I know from experience where it's actually easier to plug in the 1, 2 right now, and then find what the C would be, and then find the particular solution after that. So I'm going to go ahead and do that. I'm going to start working to find the C right here. So let's go ahead and import this equation over here. So I'm going to write negative 1/2 times, and then y to the negative second is the same as 1 over y squared. And then 1/2 x squared plus c. Okay, so let's start plugging in our points. So I'm going to plug in 2 for the y. So I'd have negative 1/2. And then 1 over the y, which in this case would be 2. So that'd be 1 over 4, equals, and then 1/2, the x is 1. So what I would end up with here is negative 1/8 equals 1/2 plus c. So c is equal to negative 1/8 minus 1/2, which simplifies to be negative 1/8 minus 4/8, which is negative 5/8. So there's what the C is. I'm going to go ahead and just plug that right back into my general solution, right back here. And I'm going to write negative 1/2 times 1 over y squared equals 1/2 x squared plus negative 5/8. And the first thing that I'm going to do to start solving this for y, this is where the tricky algebra comes into play, is I want to get the y by itself, right? So the first thing we're going to do is to multiply both sides by negative 2, which is basically the same thing as dividing by that pesky negative 1/2 that you see there. So I'm going to multiply both sides by negative 2. And I would end up with, these would cancel out. We'd get 1 over y squared equals, and then negative 2 times 1/2 x squared plus negative 5 over 8. If you'd like, you can distribute that negative 2 into these parentheses. You would end up with something like negative x squared plus 10 over 8. However, if you're not comfortable doing that, you don't have to. Remember, you don't need to simplify things on the AP. You can leave things grouped in parentheses. Okay, let's keep going. So I'm going to work as if I chose to not simplify. So what I would end up with here is 1 over y squared equals negative 2 times all that business. And then in order to solve for y, what I can do is just reciprocate both sides. Really, I'm going to just flip both sides over. And I would end up with y squared over 1, or just y squared, equals 1 over negative 2 times 1/2 x squared plus negative 5/8. Notice how I'm putting the whole right-hand side underneath 1 right here. And then to solve for y from here, all we're going to do is take the square root of both sides. So I would have y equals the square root of 1 over negative 2 times 1/2 x squared plus negative 5/8. If you remember something that we've talked about a lot before, you might think that you need to put a plus or minus on this particular square root. But in this case, because we want f of 1 to be equal to positive 2 and only positive 2, you don't want to have the negative on that square root. You only want to have the positive. So this really should end up being only the positive square root of those. And by the way, you can try plugging in 1 into this thing, and you would end up getting 2 back for the y. So if you plug 1 in for the x right there, you would end up getting 2 from the y. Remember, this is a tough problem, not necessarily because of the antiderivatives, although I do think that this antiderivative can be tricky sometimes if you're not ready for it. But this particular problem is tough because of the solving for y process right here that we needed to do. So there's a couple spots where you could go awry. Remember that the first thing you want to make sure you do is separate those variables like we did right here. That's 1 point. This antiderivative is worth 1 point. Remembering the plus c and then plugging in the points is worth another point. So you can get an easy 3 points right there, and then just sort of do your best with the other antiderivative and solving for y. All right, that is separable differential equations on domain 3. Keep doing what you're doing. If you got questions, email me or let me know.